Okay, so today we're going to be just learning about other types of probability. Today we're going to have a lot of overlap with some of the past lessons because we're going to be learning about like complementary probability, how to use casework in probability. Basically, hopefully it should be mostly a review. It's just you're looking at how to apply these concepts to more probability-based problems. However, at the end, I'm going to introduce this useful tool in geometric probability that can help you guys solve some complicated problems. Yeah, let's get started. Okay, homework review. Here's the homework review. Yeah, I'm just answering a question. All right, so did anyone do this first question on the homework? It says there's the alien, it's the alien question.
I got 90.
90? How'd you get your answer?
Well, I figured out, I think there were 6 aliens in each group. So then I just did 6 times 2 times 2. I mean times 6, because there'd be one, if there's 6 aliens, one alien would say the other alien 6 times 2 times, and then the second alien would do that, and then 3rd, 4th, 5th, and 6th.
I think you're right in saying that there's 6 aliens in each group, but I don't know if you calculated the handshakes correctly. So let me just walk through the problem. 2 groups of aliens, the A's, Auds, and Buds. All the A's know each other, all the B's know each other. The aliens from different groups don't know each other. So remember our handshake formula, or in this case, it's going to be hugs. It says a total of 30 hugs occur. Since there's an equal number of aliens in each group, that means in each group, there must have been 15 hugs. So we can use our formula n times n minus 1 over 2 equals 15. And for this, as on and found, n would equal 6. So what this means is that there are 6 aliens in each alien group. So tentacle shakes occur between aliens who don't know each other. That means all the A's have to shake tentacles with all the aliens in group B. And since there's 6 people in each group, that means each of the 6 people in group A would have to shake hands with each of the 6 people in group B. So you would actually just multiply these 2 together, and you don't need to divide or anything or do any fancy 6 choose 2 or something. The reason being because this is just there's 6 people in one group shaking hands with each of the 6 people in the other group. So we would have to just do 6 times 6, which is 36. So Anand, you're on the right track. You got the 6 people. You just didn't quite calculate the handshakes correctly at the end. Clear for everyone, or questions? Okay. Would someone like to try their hand at number 2? Okay, clear is good. Will, do you want to try number 2?
I'm a little confused.
Yeah, what are you confused about?
Yeah, just kind of a bit of everything.
Oh, okay. Are you talking about number 2 or number 1?
Number 2.
Okay. This is a question where it's like people sitting around a table, right?
Mm-hmm.
So it says a group of people arrive at a table and take seats around the table. If there's 120 possible seating arrangements, how many people arrived at the party? So this question is actually sort of working backwards. in class, we worked about like, you know how many people arrive and you're trying to find the number of seating arrangements. But this time, the question gives you the amount of seating arrangements and wants you to find the number of people. So if you remember what we talked about in class, if there's n people that's arriving at like that are going to sit around a table, you would do n factorial, but then you would have to divide by n because you have to compensate for those rotations. So since we're solving for how many people there are, we can just write n factorial divided by n equals 120 because that's the number of seating arrangements there are. So then this expression n factorial over n would just be n minus 1 factorial. That would be equal to 120. So what factorial equals 120?
5.
Yes, 5 factorial. So that means this n minus 1 part is 5. So then we can just solve n equals 6, like Wes put in the chat. Does that make more sense to you now?
Yeah.
Okay, that's great. Other questions, or is everyone clear? Okay. Yeah, number 3. How many sequences of 3 digits do not have any 2 digits summed to 18? So for this one, does anyone want to try their hand at it? Did anyone solve it?
No, I didn't even understand what the problem was asking.
That's okay. So the problem is asking sequences of 3 digits, right? So if these blanks represent places where digits can go, just 3 digits, for example, like 1, 2, 3. And it doesn't want any 2 digits summed to 18. So what that means is that you don't want something like this, where you can have, you notice that 9 and 9 sum to 18. So we don't want that. And we're just trying to find how many sequences of 3 digits don't have 2 digits summed to 18. So in other words, these can't have 2 9s in them because then they would sum to 18. So does anyone have an idea on how to do this? Or maybe what strategy you could use? No ideas? Okay, let me ask you guys a question. Would there be more numbers that have 2 digits summed to 18 or don't have 2 digits summed to 18? Yeah, there would be more numbers that don't have 2 digits summed to 18. And I mean, the reason why is just think about it. The only way you could have 2 digits summed to 18 is 9 plus 9, right? So in order to have a number have 2 digits summed to 18, it has to have 2 9s in them. But all the other numbers, they don't sum to 18. And those are the numbers we're looking for. So we have to use complementary counting for this question. Yeah, exactly, Wes. We need to find how many numbers have 2 digits summed to 18, and we need to find the total number of sequences overall, and then we subtract them from each other, finding the difference. And the difference would be our answer. So how many total sequences of 3 digits are there? Since it's just asking for sequences of 3 digits, we can use the fundamental counting principle. The first digit, we would have 10 possibilities because the digits 0 through 9. And then the second digit, we would also have 10 possibilities since it's the, yeah, there would be 1,000 possibilities since it'd be 10 times 10 times 10. So this is the total, 10,000. So now we just need to find how many sequences do have. It actually wouldn't be, the first digit actually can be 0 because in this case, it just says sequences of 3 digits. It doesn't say it's actually a 3-digit number. So it's okay for 0 to be the first digit in this case. Yeah, a little bit confusing. Sorry. So we need to find how many numbers have 2 digits summed to 18. So we can now use another strategy, casework. So what are how many possible 9s? We can split this up into 2 cases. We can have it where there are just 2 9s in a number and 1 other digit, or we could have it where there's 3 9s in a number. And we can just count how many of these there are. So by the way, for this case where there's just 2 9s in some other digit, you could actually have 3 possible arrangements of that. So you could have 9 9 and then some other digit, or you could have 9 some other digits 9, and then you could also have some other digit 9 and 9. So in total, we would have since there's 9 possible other digits for this blank here, we would have 3 times 9, which is equal to 27 possible sequences for this case. And for this case, we just have 1 sequence. So in total, we would actually have 28 numbers that have 2 digits summed to 18. So Wes, you're pretty close, but it's 28, not 30. So from there, we just do 1,000 minus 28 to get 972 as our answer. Are there questions? Yeah, so this question is a little bit complicated. It's a multi-step problem that requires you to use multiple different strategies. So it's okay if you didn't get it. Just do you know you can try to practice these strategies more, and then you'll get better at them and better at like identifying these cases. Okay, this if there's no questions, we can go on. For number 4, how many ways can Jordan distribute 13 identical pieces of candy to 4 of his friends if he wants every friend to receive at least 2 pieces of candy? This would be a sticks and stones problem. So did anyone do this problem? Would anyone like to explain how they did it?
I mean, what I did is, so if there's 13 pieces of candy to 4 of his friends, and if he wants each one to receive 2 candies, then really 8 candies are already set aside.
Yes.
So you're working with 5 candies and 3 sticks.
Yeah.
Or 5 stones and 3 sticks.
Mm-hmm.
So then you add your 8 factorial divided by 5 factorial times 3 factorial. Oh, I know how I got it wrong. I miscalculated.
That's okay. You're just at the end.
And then that was it.
Okay. Yeah. And then once you evaluate this would give us the answer 56.
Yeah, I think I got 216, but I think I calculated it wrong. So that's probably why.
That's okay. So yeah, Anand explained it pretty well. You have, since each friend needs to receive at least 2 pieces of candy from the start, you remove 8 of those pieces to just give to your friends right away. And then you have 5 stones remaining. And since there's 4 friends, that means you need 3 sticks to divide them up. So in total, then you would have 8 objects, and 8 factorial divided by 5 factorial times 3 factorial. And that's just 56. So yeah, good job, Anand. Okay, this last question. I think last class we didn't get to go over this in much detail, but I would be happy to see if any of you guys try to use the strategy we introduced. So how many paths are there from point A to point B if you can only move to the right? Would anyone like to try to number their way across this diagram? Arjun, do you want to try your hand at this? It's okay if you don't want to. Wes, do you want to try? If not, then I can show you the strategy again. Or, okay, there's something in the chat. Oh, okay. That's all right. All right, I can just show it to you guys. So remember that for this strategy, the strategy involves numbering each vertex based on how many paths there are to it. Oh, Arjun, you weren't here. Okay, that's okay. All right, I can just show you guys then. So the strategy involves numbering each vertex based on how many paths there are to it. So we can start with the starting point, which here is point A. So how many paths are there to point A? Everyone put something in the chat to show me you're alive. There would just be one path to point A. And the reason there's only one path to point A is because remember that we can only move to the right. So if we try to move if we decide we want to move somewhere, we're not going to be on point A anymore. So the only path to point A is sort of like right there. There's just one path to point A. So then how many paths would be to this point right here that I circled? Yeah, there would just be one path. And the reason for this is because from point A, you only have one path to take to get to this point. You cannot take any other path like here. You can't do that. There's just no other path. So there's only one path here to get to this point. And in fact, this same logic applies to this point too. It's only one path to get here. You just have to follow that line. You can't go around or go on some fancy path because you can't move to the left. And again, same logic applies to this one right here. It's only one path. And same goes for all the ones down here. So now we can focus on this point. How many paths are there to this point that I circled here? Yeah, there would be two paths. And this is because we add up the numbers on the vertices that are to the left of this current vertex. So this would be 1 + 1, which is 2 paths. And you can also demonstrate it. From this, you can go one path here and one path down here. So in total, there'd be 2. So now this one, how many paths are there here to this vertex that I circled? Yeah, 3. Again, because you add up this one and this one. And what about this vertex? Yeah. It would just be 1. It wouldn't be 3 or 2. The reason is because there is no path connecting these vertices together. So this vertex with the number 2 doesn't flow into this one. So we don't add that one up. We just add this one up, which is just 1. So continuing on, what would be the number at this vertex I circled here? Yeah, 2. And this vertex? Yeah, that would be 4. And this vertex down here?
Would it be, wait, could you, oh yeah, it would be 5.
Yeah, that would be 5 because you add up this one here and this one here. I know this is kind of a long path, but this is the only path that flows into this one. So you would have to add these up. And finally, how many paths?
I got 6 because do you know the 2 at the very right side that adds up to the 7? I got 1 for that because I thought there's only one path to it.
For this one, one that has, oh, okay. This actually is 2. There's 2 paths here. I can actually show you. There's one path that goes up here and here, and there's another path that goes from here to here. So there are actually 2 paths to this point.
What about wouldn't there be one more path that goes from 1 to 1, then 2, then from 1 to 3, then 4, then 1 to 2?
No, because then this part would be going to the left, which is backwards. So you can't turn that way.
Okay.
Yeah. Okay. It looks like you guys understand this. And even if you didn't understand, I hope you do now. So yay. Okay. Whew. Okay, homework review is done. Now we can get into the lesson. So far we have done some basic probability. We haven't actually dedicated a full lesson to probability though. Today's going to be that lesson. So yeah, we're going to be focusing on casework, complementary probability, and geometric probability. So I think we already covered casework in the past. I'm just going to go over it quickly. When using casework, we break the problem down into its individual cases, and we solve those cases individually, which makes it easier to solve it. Yeah, so basically in probability, what we do is we first identify the different cases for which an event could happen. Second, we calculate the probability for those cases, and then we add up each individual case's probability to get the full answer. So as an example, if 2 fair dice are rolled, what is the probability of that the sum is odd? And so we have to ask ourselves, under what conditions is the sum going to be odd? And so this only occurs when there's an even number and an odd number, or an odd number and an even number. So those would become our cases. So the first case where the first number A is going to be odd and the second number B is going to be even, we know there's like 3 odd numbers and 3 even numbers on a dice. So there's a 1/2 chance of rolling an odd number first, and then there's a 1/2 chance of rolling an even number. So this case would happen with the 1/2 times 1/2, which is 1/4 probability. So for the second case, I want you guys to do it. This case is where the first number is even and then the second number is odd. So what would be the probability for this case?
Well, the first one would have to be 1/2 chance, and the second one also be 1/2, so 1/4.
Yeah, exactly. It's just 1/2 times 1/2, 1/4. Yeah. So now we have the individual probabilities for our cases. So we have 1/4 and 1/4. So what do we do with these? Like, do we add them? Do we multiply them? Do we divide them? For this one, we would add them. And the reason is because we just basically split the problem into smaller cases. So in the end, we have to put them back together. And when you're putting something back together, that's adding. Obviously, that's not like a very technical explanation. That's the way I like to think about it. So we add these numbers together, and we get a probability of 1/2 for rolling an odd number in 2 rolls of a dice. So let's do another example. You guys can try to do this one. 3 coins were flipped. What is the probability that at least 2 of them landed on heads? Remember to split it up into the cases first and then do the probabilities for each one. Oh, and if you need help, you can just tell me. Well, remember that the total number of cases, the total number of possible outcomes would be 2 times 2 times 2. Yay, it looks like some of you put some answers in the chat. So Wes, oh wait, I just remembered your microphone. That's okay. Manit, do you want to explain how you got the answer?
Okay, so first I figured out how many ways is there going to be 2 heads, that is 3, and then I did how many ways can 3 times heads appear, that is 1, and 3 plus 1 equals 4, and then 2 times 2 times 2 equals 8, and 4 by 8 equals 1/2.
Yeah, great job. Yeah, what Manit did for this problem is he found the number of ways for each case that satisfied the problem, and then he added them up at the end and divided by the total outcomes. So good job, Manit. Does anyone have any questions?
Wait. How did he do it exactly?
He finds the number for instead of finding the probability for each case, he actually finds just the number of outcomes for each case. So for 2 heads, he found there were 3. And then for 3 heads, he found there was 1 way to do this. And then he added them up, 3 plus 1 to get 4, and then divided by the total number, which is 2 times 2 times 2, 8. So 4 over 8 equals 1/2.
Okay, thank you.
Yeah, you're welcome.
But if that's the way, then the opposite would be 2 tails and... Never mind, yeah, I got it now.
Okay. Okay, one more example. 5 coins are flipped. And what's the probability that at most 2 landed heads? Oh, many, I think at most includes the 2 heads case. At most would include 2 heads. So it'd be 0 heads, 1 head, and 2 heads. Minnie, I think you're close. I think you might have overcounted something, or maybe added it up twice. Yeah, Wes, you got it. Okay. So I'm assuming you guys at first didn't think that 2 heads counted, but it does because it says at most 2 heads, which includes 2 heads, 1 heads, and 0 heads. So for each of these cases, flipping 0 heads, flipping 1 head, flipping 2 heads, what did you guys get for 0 heads? Yeah, so there's one way to flip 0 heads. So I'm gonna write a 1 here. And you might have also found the probability of flipping 0 heads. That would be 1 over 32 because there's 2 times 2 times 2 times 2 times 2, 2 to the 5th possible outcomes. So you could find the number of ways to flip 0 heads, just 1, or you could just turn that into a probability. Both of those ways are acceptable. So what did you get for 1 head?
Well, we could land, the first one could be it, second one, third one, fourth one, fifth one, so 5.
Yeah, 5. So 5 ways to flip just 1 head. And that would also mean that there's a probability of 5 over 32. So now, what did you get for the third one, 2 heads?
It could be the first 2, then it could be 1, 2, 2, 3, 3, 4, or 4, 5, and then it could also be 1, 5, 1, 4, 1, 3, 1, 2. I mean 1, 3 just, and then 2, 4, 2, 5, 2, 3. I mean 2, 4, and 3, 5, and that's it.
Yeah, so that would be 10. 10. So the probability would be 10 over 32.
We
What?
could have done that with choose of factorials because it was kind of in a pattern. Like the last 2, like the 2 and 3 part.
Wait, what were you saying about factorials?
Could you do like where you were counting, where I was counting 1, 5, 1, 4, 1, 3? Could you do that with factorials?
That's what I was literally just about to bring that up. Yeah, I was going. Okay, you kind of read my mind. Yeah, so actually, you can count it up manually. A more efficient way would be to use factorials because if you think about it, if you have 2 heads, it would be basically you have 2 heads and 3 tails. So if you treat this like one of those word problems where you want to find the number of ways to arrange these, you could use our factorial strategy. So the last one would be 5 factorial over 2 factorial times 3 factorial. This is actually 5 choose 2, actually, and then that's just 10. So if you don't want to count all of these up manually, this is a good way to do it. And yeah, so once you have these, you can add them up. So if you do 1 plus 5 plus 10, that is 16. So you can divide that over 32, and that gives you a probability of 1/2. If you add up the fractions, you get the same thing. 1 over 32 plus 5 over 32 plus 10 over 32 equals 16 over 32, which is 1/2. Everybody got that? Oops. Okay. Whoops. All right. So we have 3 more questions, and then we're gonna, or maybe not even 3. I might skip one of them. So, all right. First question over here. Amy randomly chooses 2 numbers between 1 and 9 inclusive with replacement. What is the probability that the sum of the 2 numbers she pulls out is even?
Does inclusive mean that includes 1 and 9?
Yes.
Okay.
Wow, there's a lot of answers in the chat. All of them slightly different. Okay. What are the cases you guys made to solve this problem?
I did, because like the only ways of getting even numbers from there would be even plus even or odd plus odd.
Okay, yeah, that's right.
And the other one for not without that would be wait no yeah
Yeah,
and the total would be 15.
15?
Wait,
Where did you get 15?
20. I kind of got 15 because I thought there's 5 ways for evens to add each other since there's 5 even numbers, but I don't think that would work.
Actually, there are 5 odd numbers.
Oh.
Yeah, there's
Yeah,
5.
it's
Yeah,
not 1 to 10, it's 1 to 9. So 4
Yeah.
even numbers.
Yeah, there's 4 even numbers and 5 odd numbers. So if you were to choose 2 even numbers, it would be 4 times 4. And so if you choose 2 odd numbers, it would be 5 times 5. And then the total would be 9 times 9. So then adding the cases up and dividing it by the total, what do you get?
16 plus 25, 81 minus 16 plus 25. Okay, that is 31, 41, 40. Wait, no, that's
It's not complementary counting. We're just looking for we just have to add these up and divide it by 81.
Okay.
Yeah. So I know Wes got the right answer. So you do 4 times 4, which is 16, and then 5 times 5, which is 25. And the total was 81. So it's 16 plus 25 divided by 81. So that is 41 over 81. That is the probability that I will choose 2 numbers whose sum is even. Okay, are there questions about this question or problem? Okay, I'm gonna skip the second problem because it's a little bit redundant. So instead, we're just gonna do number 3. All right, every time these 2 wheels are spun, 2 numbers are selected by the pointers. And I'm assuming these darker things up here are the pointers. So what is the probability that the sum of the 2 selected numbers is even? I think this problem is an AMC problem. The other ones aren't. Hmm.
Would there be like Because would there be three times 4 ways?
Yes, there would be total 3 times 4 ways.
So 12 ways in total.
Okay, so the cases you guys should have set up were even number and then an even number, and then an odd number and an odd numbers. Those are the cases you should have set up. So we can like look at it one spinner at a time. So for this first spinner here to the left, what is the probability that you get an even number?
2 out of 5. I mean 2 out of 4.
Yeah, 2 out of 4, which is just 1/2. So then for the second spinner here, what's the probability that you also get an even number there? Yeah, this would just be 1/3 because 6 is the only even number here. So that would be 1/3. And then that you can just multiply out, that's 1/6. And so then for the odd case, what's the probability that you get an odd number for the first spinner? Yeah, 1/2. And then so then of course the probability of getting an odd number on the second spinner would be 2/3. Yep. And so we can just multiply it out. This is actually just 1/3. So now we just add these together. So 1/3 plus 1/6. If you change the denominator, then this would just be 3/6, which is 1/2. And I did it this way where I'm like actually multiplying the probabilities, but you can also do it by multiplying the total number of outcomes and dividing it by the total at the end. Either way, you should get the same answer, which is 1/2. Okay, are there questions? Okay. All right, those are just the answers, which we already went over. Okay, now we're going to move on to the other second topic for today, which is complementary probability. Basically, complementary counting, we basically find the opposite of what we're looking for and subtract it from the total number of outcomes. And complementary probability, where if we find ourselves in a similar situation where the desired probability is more difficult to calculate than the opposite, then we find the opposite probability, but we subtract it from 1. The reason we're subtracting it from 1 is because if you add a probability and its opposite or complement up, they should equal 1. So as an example, the probability that there will be precipitation today and the probability that there will not be precipitation today must add up to 1 because no matter what, you have to either have precipitation or don't have precipitation. So it is guaranteed that you will either have it or don't have it. There won't be any other situation where for some reason you're kind of like, you're not having it, but you're also having it. So anyway, we find if the thing that we're looking for is hard to calculate, we can find the opposite of that and subtract it from 1. And that can help us find our answer in an easier way. So for example, I roll 2 fair 6-sided dice. What is the probability that their sum is less than 12? Well, the thing is, if we actually work out all the possible ways their sum is less than 12, then we need to find if their sum is 11, and if their sum is 10, and if their sum is 9, and 8, and 7, and 6. And yeah, it's just going to be a big pain. So instead, what we can do is find if their sum is greater than or equal to 12, which in this case will just have to be equal to 12. So we can find this probability, and then we subtract it from 1, and this would give us our answer. So now I'm going to work it out. So the probability that you roll a 12. So actually, what's the only way you can roll a 12 on 2 6-sided die?
By adding the 2 6s.
Yeah, the only way you can roll 12 is by getting 2 6s and adding them together. So,
But it's 136.
yeah, so the probability would be 136, 1 over 36 for this, because there's a 1/6 chance that you roll 6 in the first one, and then a 1/6 chance that you roll in the second one. So the probability that you roll a double 6 is 1 over 36. Now what we do is we subtract this from 1, because there's a probability of 1 that you just roll anything, right? So if you subtract this from 1, you get 35 over 36. And this represents the probability that I get a sum that is less than 12. And this is a lot easier than just adding up every single possible sum's probability. Okay, are there questions on how complementary probability works? Okay, let's do another example. At the beginning of the day, there's 10 available parking spots in a parking lot, and each parking spot has a 1/2 chance of being occupied by the end of the day. What is the probability that by the end of the day, there are at least 2 parking spots still open? So, first of all, this problem actually also requires casework. So first of all, what is the opposite of having at least 2 parking spots open? If you have 2 parking spots open, that means you can have 2, 3, 4, 5, or more parking spots. However, the opposite would be 1 or 0 parking spots open, because that's not at least 2 parking spots. So these, in fact, are the cases that are the opposite of what we're looking for. So PS is going to represent for parking spot, because I'm not going to write the whole thing out. 1 parking spot and 0 parking spots. Those are the cases. So now we just need to calculate the probability that will happen. So what's the probability that only 1 parking spot is going to be open by the end of the day? Yeah, Manit, or wait, let me see. Is that Manit or Manit? Sorry. That would be, yeah, Manit. There are 10 ways for 1 parking spot to be open, because you could have the open spot be the first spot or the second spot or the third spot, etc., all the way to the end, 10th spot. So there are 10 ways for just 1 parking spot to be open. And then the total, however, in each of those cases, you have each parking spot has a 1/2 chance of being open and a 1/2 chance of being occupied. So the total probability would be 1/2 raised to the 10th power. So this would be 10 over 1,224. That's for 1 parking spot open. For 0 parking spots open, how many ways are there for that to happen? Yeah, there would just be 1 way. So that'd be 1, and then we multiply by 1/2 raised to the 10th power. Reason again is because each parking spot has a 1/2 chance of being occupied. So it'd be 1/2 times 1/2 times 1/2 and all the way. So that would be 1 over 1,024. So now what we have to do is we add these up. We add them up to find the total probability that only 1 parking spot or 0 parking spots are going to open. So that is 11 over 1,024. So finally, what do we do now? We have the opposite of what we're looking for. So what do we do with this opposite? Yeah, we have to subtract it from 1. So 1 minus 11 over 1024, that's just if you change the common denominator, 1024 minus 11 for 1024. So the total probability would be 1013 over 1024. That is the chance that there are at least 2 parking spots open by the end of the day. Okay, are there questions about how I got this or anything? Because I appreciate questions. Okay. Okay, one more example. I flipped 5 coins. What is the probability that at least 2 land on heads? So this is actually kind of similar to a problem we already had in this lesson today. However, the previous one said at most, but this one says at least. So I want you guys to try to do this, and yeah, I'll give you like a couple minutes to work it out.
Do we have to do this complementary way? Because like I feel like it's the same either way.
I would prefer for you to do complementary, because if you decide to not use complementary counting, you'll have to find the probability that lands 2, 3, 4, and 5 heads. But if you do complementary, you just need to find 0 and 1.
Like at most 2, not at least.
Yeah.
So would it be how do you find out the total amount of flips?
5 coins. So for each coin, there would be 2 possibilities. So you do 2 to the 5th.
10?
2,
Okay.
2 to the 5th. Remember
Okay.
the fundamental counting principle. You have to multiply these together.
Okay, thank you.
Yep.
Yeah. 32.
Okay. Monosvi, do you want to explain how you got your answer? Sure, you can type it out. Okay, while Monosvi is typing his answer, I'm just gonna started off. So the question is asking that the probability that you flip at least 2 heads. So this would mean since if you just solved for at least 2 heads, you would have to find the probability of flipping 2 heads, 3 heads, 4 heads, and 5 heads. But if you use complementary counting, you would just need to find the probability that flips 0 heads or 1 heads. So this would be the rationale for why you use complementary counting. So now we just need to find the probability for 0 heads and 1 heads. So for 0 heads, there is, no, I want to wait for minus b. Okay, for 0 heads, you have one way to do this because the only way you can flip 0 heads is to get all tails. And to get 1 head, you have 5 ways to do this because you can have heads in the first, second, third, fourth, or fifth position. So you'd have 5 ways for this one. And so the total ways would be 2 to the 5th power because of the fundamental counting principle. Each coin has 2 possibilities. So the total number of possibilities would be 2 times 2 times 2 times 2 times 2. So that is 32 possible ways. Yeah. Yeah. So then the combined number of ways for 0 heads and 1 heads is 6 ways. So the probability would be 6 over 32. I would prefer to simplify because it makes it easier when you're subtracting things. So that would be 3 over 16. And subtracting that from 1 minus 3 over 16 equals 13 over 16, which is our answer. So yeah, good job, minus b. Okay, are there other questions about how to use complementary counting or when to use it? Okay. All right. So I have I have a couple of other questions. I think most of these are AMC questions. So yeah. Okay. You guys can try to work these out. A complete cycle of a traffic light takes 60 seconds. During each cycle, the light is green for 25 seconds, yellow for 5 seconds, and red for 30 seconds. At a randomly chosen time, what is the probability that the light will not be green? Express your answer as a common fraction. Yeah, good job, everyone. Yeah, for this one, this one's pretty simple. You can actually not use complementary counting for this one if you don't want to. But if you do use complementary counting, it might look like this. The green light is green for 25 seconds. And the total time is 60 seconds. So the probability that it will be green is 25 over 60, which simplifies to 5 over 12. And so the complement of that is if it's not green. So you do 1 minus 5 over 12, and that's just 7 over 12. Okay, looks like it was pretty easy for you guys. Second question. A game board spinner is divided into 3 parts labeled A, B, and C. The probability of the spinner landing on A is 1/3, and the probability of the spinner landing on B is 5/12. What is the probability of the spinner landing on C? Express your answer as a common fraction. Yeah, this one kind of forces you to have to use. Okay, yeah. For this one, you would add the probability for A to the probability for B, and then you subtract that from 1 to get C, because the board game spinner is only divided into A, B, and C. So 1/3 plus 5 over 12, that is 4 over 12 plus 5/12, that's 9/12, which is also equal to 3/4. So the complement of that would be 1/4, which is the probability of the spinner landing on C. Good job, guys. Okay, and finally, 2 fair 6-sided dice are rolled. what is the probability that at least one of the dice shows a 1? Okay. I'm not sure how you guys all managed to agree on 1/3. I don't think that's the right answer. Would someone like to explain how they got 1/3? I'm a bit perplexed.
Oh, 1/4. We all calculated it wrong, I think.
Okay. Will, do you have a question to answer?
I was just gonna say how I got 1/3.
Sure. Go ahead.
So I thought that 1/6. So basically, there's 1/6 of a chance that you roll a 1 on a 6-sided dice, and so you roll 2 dice. So I did 1/6 times 2, which is 1/3.
Oh, yeah, I'm not sure that would be right. The reason being that actually for this one, you would have to look if you did it that way where you were looking for how many ways you could roll a 1, you could either have it where you roll a 1 on both die or you don't roll a 1 on one die. I'm not sure you can just multiply it by 2 because remember that multiplying it by 2 is the same thing as just adding it up twice. So I'm not sure that would work. Does anyone have another way they did it? Honestly, you got 1/9. I mean, how'd you get 1/9? You could just quickly type it in the chat because I know you can't unmute.
Oh, wait. I think I did it wrong.
Okay, I'm gonna show the solution while I'm on SV. So basically, okay, all right, that's okay. To do this problem, we would have to think about it. Well, if you want to solve it where you want to find it, the probability of showing it a 1, there's a lot of different ways you could do it. You could have a 1 show up on both die. You could have 1 show up on only one die. So you have 3 different possibilities. And honestly, it would probably be more efficient if you just calculate the opposite of it, where a 1 doesn't show up on either of the die, but then you subtract that probability from 1. So you use complementary counting for this. So to do this, what is the probability that in just one dice roll, you don't get a 1? Yeah, it would be 5/6 because as Will previously stated, the probability of rolling a 1 is 1/6. So the probability of not getting a 1 is 5/6. So that's for one dice roll. And so we can do that again for the second dice roll. The probability that it doesn't come up as a 1 would be 5/6. So if we multiply these together, that gives us 25 over 36, which represents the probability that we don't get a 1 on either dice rolls. So now what we can do is we can subtract this probability from 1 to get the probability that at least one of the dice shows a 1. So that'd be 1 minus 25 over 36, which is 36 minus 25 over 36. That just gets 11 over 36, which is our answer. And I think many you fixed your answer. So yeah, good job. Yeah, are there questions on why I did this rather than some other way? Okay. All right then. I mean, you guys can go enjoy a nice, juicy 5-minute break, and I guess be back at your computers by the end of it. So, yeah, enjoy your break. Okay, hi people, I'm back. And yep, timer's over. All right, so hopefully you have a good understanding of complementary, casework, probability, and you can hopefully tackle different types of probability problems now. However, there's one type of probability we haven't gone over yet, and we didn't introduce to you yet, and that's geometric probability. Basically, just as it sounds, geometric probability problems involve geometry. For example, the probability of throwing a dart onto a certain part of a dartboard. In geometric probability, what we do is we first identify what the problem's asking, and we identify which areas of the shapes that we need to calculate areas of. And then once we find the area of that part of the specific part of the shape we want, we divide it by the total area. So, and then that would be the probability. So as an example, the typical geometric probability problem would involve some kind of dartboard. This is just a normal dartboard, but you can basically find any type of dartboard, like wonky dartboards, square dartboards. So it goes something like this. I randomly throw 2 darts, and each dart can only land in one of the rings. What is the probability that I score at least 90 points? So first of all, in what ways can I score at least 90 points? Like, what are the point values I need?
At least you have to throw both your darts at the red area, or 1 dart red, 1 dart orange.
Yeah, that's right. There are essentially 2 cases, although technically 40 plus 50 and 50 plus 40, even though they're kind of different, I'm just going to consider them the same. So you either have a 50-50 or you have, oops, hold on, okay, there, 40-50. Oh my gosh, very bad handwriting. Yeah, so those are our cases. Now, obviously this case, once we get the probability for this, we need to multiply by 2 because there's 50 and 40, but we can deal with that when we come. So yeah, those are our cases. So now what we need to do is that we need to find the areas of each of those regions. The reason is because we know we want a 50, but we need to calculate the probability of like getting a 50. So first of all, what's the total area of this entire dartboard? And I hope you can remember the formula for the area of the circle. And oh, by the way, you should try to express your answer in terms of pi. So don't multiply pi out. Yeah, it would be 25 pi because the radius is 5 because it's 1 plus 1 plus 1 plus 1. And so then it would be 5 squared times pi. So the total area is 25 pi. Now, what's the area of just this red part here, the 50-point line? Yeah, it would just be pi. Because the reason is because this radius is just 1. So it would be 1 squared times pi. That's just pi. So now, what would be the area of this orange part? Just the orange part, though. Just the orange part. Yeah, this orange part would have an area of 3 pi. The reason is
1, like the area, or like the distance.
Yeah, the 1 is sort of like the distance from each circle. So it's sort of like this distance.
Okay, well, I mean, wouldn't you just calculate like the diameter of the orange circle?
Yeah, you would have to calculate the diameter. Well, you only need the radius. You need the radius of the orange circle, but once you find the area, you need to subtract this red part from inside it.
Yeah, but do you really need to do that? Because everything inside, every possibility for 90 will just be inside the orange circle.
Oh, that's true. Well, that's another way to think. I actually did not consider that. Let's follow this way first, and then I'll see if that way works. Actually, no, that would not work. The reason is because if 2 darts land in the 40 area, that wouldn't add up to 90 or more. Because that would only add up to 80 then. So you would have to consider each area independently. So the area of the orange region would be 3 pi. So now we basically have our probabilities for getting a 50 probability. We can calculate the probability for getting a 50, a 40, and the total. So the probability for getting a 50 would be pi divided by 25 pi. So that would be the probability of getting 50 is 1 over 25. And then the probability of getting 40 would be 3 pi divided by 25 pi. And so this will be 3 over 25. So now we have our probabilities. We can now calculate the actual probability for each case. So if I erase some of this stuff. Okay, for a case where it's like a 50, you toss 2 50s, that probability would be 1 over 25 for the first 50 times 1 over 25 for the second 50, and that is 1 over 625. And then for the second case where it's 40 and then 50, or vice versa, it would be 3 over 25 times 1 over 25. And then we would have to multiply by 2. Remember that multiplying by 2 is the same thing as adding up the same thing twice. So we're just saying that it could go either way. So we need to multiply by 2. So that is 6 over 625. So let me just make sure. Yeah. So then finally we add these up to get our probability. Well, we add 1 over 625 plus 6 over 625. That is 7 over 625. That's our answer. Okay. Does anyone want me to go over anything that I just showed? Okay. Geometric probability problems, a lot of times they require you to be kind of creative because you, I mean, they're a little bit more unconventional than normal probability problems. And I like this problem. It's a good example of why you need to be creative when thinking about this. So this dartboard is a regular hexagon, which is divided into sections numbered from 1 through 6. The area of section 1 is twice that of section 2. And the area of section 5 is 3 times the area of section 6. A DC is blindfolded and throws 2 darts at the board. Assuming that both land on the board, what's the probability the sum is 10? So first of all, what are the different ways she can get a sum of 10 by throwing 2 darts? Like, what are the numbers or values she needs to get?
It have to be exactly 10?
The sum is 10. Has to be exactly 10.
Okay, so then there's 6 and 4.
Yeah.
That's all.
There's another one.
5
Yeah.
plus
Have another one. Oh, I got now.
Yeah, 5 plus 5. But yeah, those are basically the only ones. Obviously, 6 and 4 can be swapped around to 4 plus 6, but we can ignore that for now. So these are the values. Basically, we want to look at this, this, and this. So in order to calculate the problem, so we're looking at the numbers 4, 5, and 6. So how do we calculate the area of this? Like, I don't like for this one, it's kind of a bad idea to try to use some like super complicated equation to calculate the area of each of these triangles and trapezoids. So in fact, we can do this pretty clever thing.
Just, you don't have to actually calculate the area, you only have to kind of.
Yeah, you don't actually need to calculate the area. You just need to find, well, you do sort of need to calculate the area, but you don't need to find like the actual area. Instead, what you can do is you can draw lines dividing this picture up into equal parts. So with so you can see that each of these triangles, like I'm just going to outline one of these triangles. We can call each of those triangles be 1 unit or something. It doesn't really matter. So for example, try, for example, the area of number 6 would have an area of 1 unit because it's just made up of one of these triangles, right? But then number 5, the section number 5 would have an area of 3 because it's made up of 3 of these little triangles.
But how would you find the total area if?
You can count up how many triangles there are.
Oh no, I see now. Yeah, and I was looking at like the area where there's no triangles in 2, 1, and 3, but there's just like the black lines, right?
Yeah, those are just black ones. We can ignore them because there's actually a triangle here, triangle there. So the triangles do cross the border, but that doesn't really matter. So then, of course, the area of number 4 would be 1, 2, 1, 2, 3, 4, 5. And then this part would actually have an area of 6. This is just 2 halves of a triangle that are just laid off across each other in a different way. So this area of number 4 would be, section 4 would be 6. Okay, so now we can find the total area. And for that, we just count up how many triangles there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 total triangles. So let's write that down. Okay, now that we have all of the areas we need, you guys try to find the probability that a DT, when she throws 2 darts, she'll get a sum of 10. So you guys try to do that.
Would it be 13 or 24?
Let me check. I still have to solve the problem on my side too.
Why do I get 23, but I probably just miscounted it? Oh, I forgot to multiply. Instead of just, I added instead of multiplying. Come on, that shouldn't work.
Okay, we have one right answer. All right, I'm just going to go over the problem now. So the correct answer is 7, at least I'm pretty sure, is 7 over 192. Yep, it is 7 over 192. So to get this, first we could just look at the case where she throws a 5 and then a 5. So if she throws 23 triangles, Anna and Du, maybe you're counting these 2 top triangles twice, or sorry, 1 time, because there's.
Yeah, probably so I was doing.
Okay, yeah. If we look at the case where she throws a 5 and then a 5, the probability of throwing a 5 is 3 over 24. Again, it would be 3 over 24. That's just 1/8 plus 1/8, or times 1/8. This is 9 over 576. I'm going to keep that in that form because then they're already in a common denominator. Then the probability that she throws a 4 and then a 6 would be 6 over 24 times 1 over 24. But then you do have to multiply by 2 because, again, it could be 4 and then a 6, or it could be a 6 and a 4. So since you're adding them both up, I just multiply by 2. So this would be 12 over 576. So if we add these up, 9 over 576 plus 12 over 576, that is 21 over 576, which when simplified is 7 over 192. So that's the probability that she throws a 10. Okay, is that clear for everyone? Okay. All right. Just one more example. I like these types of examples. Just read the question carefully and think about it. So a random point is chosen on the line below in between points A and B. Points A and B are 6 inches apart from each other. What is the probability that the point is less than 3 inches away from point A, but greater than 4 inches away from point B? And if you really want to, you can draw this on your paper, maybe mark off 6 inches. I mean, not like actually mark off 6 inches, but like put notches wherever there's 1 inch, and then see.
Would the random point on the line have to be like a whole number away from one of them? Because
No, it can be anywhere. It can be like 3 point. It could be a decimal fraction, whatever. And by the way, it has to be between point A and B.
Infinite amount of.
Yeah, there are an infinite number, but it's asking for the probability. So even though there can be an infinite number of possible positions, the probability is not infinite. And if you need some help, here's what you should be looking for. You should be solving for the length of the part of the line that satisfies this question divided by the total length of the line, which here, yeah.
It'd have to be. I guess it'd be like 2 inches. So like 1/3.
I think that's right. All right, let's see. Yes, it is 1/3. Okay, good job, guys. So yeah, for this question, what I like to do is I like to first mark off each inch. So each of the distances between each of these markings is going to represent 1 inch. So 1 inch from here to here, 1 inch from here to here. So now we can sort of, I don't know if you've taken an algebra class yet, but if you know about graphing inequalities, basically we're shading on which parts of the line meet the criteria. So first of all, this says we want the point that is less than 3 inches away from point A. So in order for it to be less than 3 inches away from A, we want it to be in this part of the graph because it's like 1, 2, 3 inches. So it needs to be in that part of the graph. Also, the point should be greater than 4 inches away from point B. So if we count 1, 2, 3, 4. So we want the point to be in this part of the graph also. So now we just need to find the area that satisfies both of these regions. And of course, that's the region that's in both of them. So it would just be this part here. This area has a length of 2 inches. And since the total length is 6 inches, the probability of the point landing in that region would just be 2 over 6 or 1/3. Is that clear to everyone? If not, ask some questions. Okay. Yeah, this is the same diagram. I just did it on Google Slides. All right, we're gonna do some more practice problems. We're not gonna do all the problems. Let's do this one first, and then we can skip one and do with the other one, so we can cover the last topics and do a Kahoot. All right, so in this dartboard shown below, it's a very weird dartboard. The outermost circle has a radius of 8 centimeters, and each smaller circle has a radius that's 1/2 of the radius of the next larger circle. Find the probability that a randomly thrown dart will land in the white area, and that should read land. Okay, I have 2 answers in the chat, which are identical. However, it's not right. And in fact, the last time I taught counting probability, which was last week, they also fell into the same trap. Okay, here's the thing. To find the, we just need to find the area of the white region. So the total, what's the total area of the dartboard? Yeah, 64 or 64 pi, but it doesn't matter. The pi doesn't really matter. 64 pi. This is a total area. So what's the area of this region here? Yeah, this would be 16 pi. However, that's just the area of the circle. Is the actual white region 16 pi? No, it's not, because there is a darker region subtracted from it. So in fact, what you need to do is, so you need to subtract this darker region from that light region. So it'd be 16 pi minus the area of this region, which would actually be 4 pi. And then after that, you need to add back this smaller white region, which is inside here. That has a radius of 1, so it's plus 1 pi. So this whole thing should be over 64 pi. So this would be 13 pi over 64 pi, which of course is just 13 over 64. Yep, Will, you got it. So you have to be a little bit careful with these questions, because the way I like to think about it is that these circles are layered on top of each other. You first have this larger circle, and then on top of that layered is a white circle. And then on top of that is a darker circle. And then on top of that is another lighter circle. So the darker circles would subtract from the lighter. Each new circle would either add or subtract from the previous circle, depending on which one you're solving for. So are there any questions about this? Okay. All right, this question. A spinner is divided up into sectors. What is the probability that on a random spin, the spinner lands in a sector that has an angle of 45 degrees? And if you don't know what a sector is, it's basically, think of a circle and think about a slice of the circle, like a little pie piece of the circle. That little pie piece is a sector, and the angle of the sector is the angle that the sector has. So in this case, it's 45 degrees. Yeah. The answer would be 1/8, just as a lot of you got. That's great. And the reason why the answer is 1/8 is because you don't actually need to find the area of the sector for this question. The reason is because the angle of the sector directly correlates with the area of the sector. Since a full circle is 360 degrees, and the sector is 45 degrees, we just do 45 over 360, and that equals 1/8. So for sector problems where it's like a spinner and you have an angle, you don't need to find the area, you just need to look at the angle of the sector. Oh, whoopsie. Okay, this question is probably going to be our last question before we either move on or do a Kahoot. So a random point is chosen on this line. Point C is between points A and B. AC equals 4 and BC equals 2. What is the probability that the point is closer to A than B, but further from A than to C? If you're confused about the wording of this problem, just ask me because I kind of wrote it.
Oh, I got it now. So we had a problem like this one before.
Yeah, we did have a similar one. Okay, it looks like a lot of you got 1/3. I don't think that's the right answer. Yeah, I kind of did show the answer.
Oh,
Right?
I get it now.
Okay, I'm
I
gonna
know
walk through.
grades 1/6 though. Like,
Okay, that's good. I'm still gonna walk through it though. So AC equals 4, BC equals 2. So I'm gonna like put marks to divide the line up into 1-inch pieces there. So we want the probability that the point is closer to A than to B. Let's just first look at this part. It's closer to A than to B. The place where the point is equal distance from both A and B is this. This is like the 3-inch mark where it's like 3 inches from A, 3 inches from B. And since we want it closer to A than to B, that means we want it on this part here. Okay, next, the question says we want it further from A than to C. This wording is a little bit backwards. What this means is that we want it closer to C. So looking at the from A to C, this middle point right here, this is sort of like the 2-inch mark where it's 2 inches from A and 2 inches from C. And since we want to be farther from A, we want this region right here. So now we just look for the overlap. And since the overlap just is right over here, this part has a length of 1 inch and the total length is 6 inches. So the probability would be 1/6, which is 1/6. So yay. Are there other questions? Okay, moving on. Okay, so far, geometric probability has been pretty geometric, like the problems have stuff to do with geometry. However, some types of problems don't appear to have anything to do with geometry, and however, they still use graphing. I'm gonna go through this kind of quickly. You guys won't have any questions on your homework or in the Kahoot about this, but I still think I should go over it because it's actually a really neat strategy. So I think this problem is not an AMC problem, it's a math counts problem. So it goes something like this. Anna and Taylor would like to meet together at Starbucks to have coffee. And they agreed that once one person arrives, that person will wait for no more than 15 minutes for the other person. If the other person doesn't arrive within that 15 minutes, the first person will leave and they won't have coffee together. If Anna and Taylor will each arrive at the coffee shop at a random time between 9 o'clock and 10 o'clock a.m., what is the probability that the two will meet together to have coffee? And this question is hard because the thing is, time is continuous. It doesn't like it doesn't increment like in 1 minute chunks or something like that. It's continuous. So what we can do is we can graph it. We first set up our axes, and let's put times on the x-axis. And this we can mark 15-minute intervals. It doesn't really matter though. These are the possible times when Anna can arrive. And if we also do the same on the y-axis, these will be the times that Taylor can arrive. And here are grid lines. So basically, now if you think about it like this now, if Anna arrives at 9 o'clock, then that means Taylor can arrive at some time like from 9 o'clock to 9:15. If Anna arrives at like 9:15, then Taylor can arrive sometime from 9:15 to 9:30. If Anna arrives at 9:30, Taylor can arrive anytime 15 minutes afterwards, and so on and so forth. So even if it's like Anna arrives sometime in the middle, there's still just this 15-minute interval where Taylor can arrive, but they can still meet together to have coffee. This, in fact, should be shaded. This area. Those represents the times where Anna can arrive and Taylor can also arrive to have coffee. Now, if we do the same thing for Taylor, so say Taylor arrives at 9 o'clock, right? And that means Anna can arrive anytime from 9 o'clock to 9:15. And if Taylor arrives at 9:15, that means Anna can arrive anytime from 9:15 to 9:30. And if Taylor arrives at 9:30, then Anna can arrive anytime 15 minutes afterwards, and so on and so forth. And basically, this also becomes a shaded region. And now I'm going to make this more pretty. Basically, it looks like this. This shaded region represents all the times where the girls can arrive, but still like meet to have coffee. So for example, if you just choose a random point, so here, then these times should be less than 15 minutes apart. So basically, we now have this graph representing all the times that the two girls could arrive and also all the total possible times. How does this help us calculate the probability? Well, the probability now is just the area of this gray area divided by the total area of this graph. Because the gray area represents the times that satisfy the problem. So the total area of the graph, in fact, we don't even need to calculate the area in like minutes or something. We can just look at the squares. So in total, there are 16 grid squares, right? And the graph, the shaded area, has 1, 2, 3, 4, 5.5, 6, 6.5, 7. Wait, 1, 2, 3, 4, 5, 6, 7. Sorry, 7 squares. So in fact, the probability of the two meeting together to have coffee is 7/16. I'm going to wait a moment. Okay. Does anyone have any questions? Also, I don't expect you to understand this like right away. It was kind of hard for me when I first learned it. Essentially, you should just take away that if you have some problem where the thing you're analyzing is continuous, for example, time, and you have multiple people like that you need to keep track of, what you can do is graph it. I actually think these can only really be solved through a graph. I don't know how else you would solve it because specifically it's just, I mean, I guess you could solve it without the graphing it, like actually graphing it, but you still need to have like a mental image of that graph in your head in order to visualize it. So really, for this type of question, the graph is the way to go. I don't know if there's some other way to solve it, but I'm sure they're more complicated than this. Yeah. I'm not going to go through much more of these problems. I have a couple of other examples. When I post the slides after class, you can go through them and like look at them and see how they work. But otherwise, I think we can just go to the Kahoot. Okay, let's go to the end. Okay. Okay. Oh. Okay, I'm assuming that's not actually Sai because Sai shouldn't be here, but okay. Arjun, if you plan to join, and then Many, if you want to join, then you can. Wait, actually, I don't know who always sighs, so I don't know if any of you guys. Oh, someone disappeared. Oh, okay. All right, I'm gonna be starting in like 10 seconds. So if you want to join, then you better join soon. All right, let's get started. Other types of probability. Okay, first question. Random point is chosen on segment AD. What's the probability that it's on segment AB? Oh, yay. Most of you guys got it. Yep. Wow, leaderboard. Good job, Monosv. Monosv always sign many are top 3. Okay. Random point is chosen on segment AD. What's the probability it's not on BC? Okay, nice. Same thing again. Always Sai is in the lead, keeping Sai's legacy even though he's not here today. Area of the rectangle. Rectangle, by the way, it's not the gray area, just the rectangle. Oh yeah, the answer is banana, by the way. Yeah, area, we're just asking for the rectangle, not like the gray area or anything.
Wait, wouldn't the? Oh, I thought like the white parts were not part of it. Like weren't part of the rectangle.
Yeah, it's just asking for the rectangle, nothing fancy. Okay, this time it's asking for the triangle.
No, I messed up.
Oh no. Did you forget to divide by 2?
I forgot. Like last round, I divided by 2, like to minus, but this time I forgot.
Oh no. I remember I had to make some of the geometry Kahoots, but I forgot to divide by 2 for all of the triangle problems, which was bad.
Quick question: who wrote these answers?
Not me. I didn't write the first like half of this Kahoot, but all the rest I did. So, I mean, okay, ball is dropped randomly. Find the probability that it'll land in the triangle. Yeah, I didn't write these problems with this diagram. I just took those just because. Oh yikes, honesty. Yeah. 6/35. Oh wow, I literally don't know.
Divide by 2 again.
Oh no. Yeah, that's the one thing. It always gets me. Outside of the square. So you would use complementary counting.
The small square, right? The small square?
Yeah.
Yeah.
Okay, nice. Okay, what is the probability that the spinner will land in section C? I didn't write this question either. Oh, okay.
I forgot the full circles is 360, so it took me so much longer.
Yeah. I don't know what this math thing is. Yeah, if in case it ever happens, if Kahoot doesn't let you answer, I don't know why. Sometimes it happens to me where it's like I'm on my phone and I click, but it's not like going anywhere. I just spam it until it goes. That's basically what I do if I'm in that situation. What's the probability that the spinner will not land in section B? Not land in section B. Yay.
I kind of guessed that one, but I didn't fully guess. Like I knew the answer, but I just guessed this is probably going to be the closest like simplified version of it.
Yeah, that's a totally valid strategy, especially given that the other ones are not really. Like this one's not simplified. In fact, it's the same as this one. This one's not even a fraction. So yeah, that works. Okay, probability that in 4 flips of a coin, 2 heads are tossed. I wrote this question. Oh wow, all the answers came in at like almost the same time. Oh my gosh, all 5 of you. Actually, I think there's 6 people, but that's okay. 4 flips, 2 heads. Yep, 6 ways to do that divided by 16, so that's 3/8. Nice. Okay. Oh, okay, I hate this question. The nth day of the week has a 1/n chance of rain. What's the probability of it not raining any day? Okay, actually, you know what? Sorry. I don't like that question. I don't know why I put it in. Okay, 2 marbles are drawn out without replacement. What's the probability of pulling out at least 1 blue marble?
Kind of just guessed on this one because I got an answer, but it wasn't
Yeah, that's okay. I don't know if I gave you guys enough time. Yeah, for this one you do 4/7 times 3/6, and that gets the probability of not pulling out a blue marble, and then you subtract that from 1. Oh wow, honestly. Okay, 3 marbles drawn out with the placement, probability of pulling out at least 1 blue marble. This one you have more time.
What's 2/7? I know the answer is 2/7, but it's not on there.
Oh, only one person got it right. Okay, so basically you do 4/7 because there's marbles that aren't blue at first, times 3/6 times 2/5.
It's only
That gives you the probability of not pulling out a blue marble at all. So that simplified is 4/35. So then you do 1 minus that to get the answer, which is 31/35. So yeah. Okay, 5 marbles drawn out with the placement. What is the probability of pulling out at least 1 blue marble? I'm gonna be sad if you guys don't get this right. There's only 20 seconds on this one for a reason.
wait, hold up.
No one got it right. Oh
I
no.
realized that at the very last second. I was just thinking about it, and then I had to guess.
Oh, this makes sense.
Yeah, there's only 4 non-blue marbles. So if you pull out 5 marbles, one of them has to be blue.
Yeah,
Sad,
got
you
that
guys.
at the very last second, but then
Yeah. Okay. I'm sad that you guys didn't get it right. Okay, but
how would you know how many people are in the classroom?
shoot, to those 4 students who didn't put their name on it. Just to the teacher's only handing back the papers to the no name people.
Okay.
Uh-oh. Okay, let's check out this problem. So basically there's only one way that gets everything right, okay? There's only one way for the teacher to give it back to every student correctly. So then how many total ways are there for her to give the papers back to any of one of those 4 people?
Factorial.
4.
Yeah, that'd be 4 factorial. So it'd be 1/24.
I got it now.
Okay. Okay. There's gonna be a similar one that's like, I think, right up next. So think about this one. This is also sort of a trick question. So, oh no, none of you guys got it right. Think about it like this. Is it possible for a teacher to hand 3 out of 4 papers back to the correct student? Exactly. Because if 3 out of 4 students are correct, then the last person also has to be handed to the correct paper, right? A, B, C, D, and their papers are A, B, C, D. If A, B, and C all get their papers, then D has to also be right. So it's impossible to get exactly 3 out of 4. You have to, there's no 3 out of 4 correct. It's either all 4 or something other than that. There's no 3 out of 4. I hope you guys understand that. However, there are ways to like get 2 correct. And I think there's ways to get 1 correct, but you cannot have 3 out of 4. It's okay, you guys. I gave you some tricky questions. Okay. 2 numbers from 1 to 5 are chosen with replacement. What's the probability that their sum is prime?
I've got like how many numbers could be added? Wait, no.
2 from 1 to 5 inclusive.
I got how many numbers, but I can't.
Actually, I might have gotten this wrong. Shoot.
Yeah, I don't see my answer on there.
Here, let me see. All right, 1, 2, 3, 4, 1, 2, 3, 4.
I
Yeah,
can't the answer.
yeah, I think I messed up.
The answer should be like 7/10.
I mean, I got like 1, 2 as the prime numbers, 1 as the prime numbers, and
Yeah, I kind of messed up. Wait. Oh, must have got it right. Okay, I'm actually not sure how I got it.
it is best.
Yeah, this one is sort of a mistake. You can't have 1 and 6, but I think I included those on accident. So, oops. Sorry, guys. Okay. All right. What's the probability that the randomly thrown dart lands in a shaded area, assuming all quadrilaterals are squares? And by the way, these are midpoints. So this is the midpoint of the square. That's the midpoint of the square. Okay. For
Pretty
this one, in fact, for this one, notice this one thing. First, ignore the fact that there's a bunch of other squares in the middle, okay? Pretend it's just this square and a light square here. These squares are 1/2 the area of the total. So this white square would be 1/2 the area of the big square, and then this square would be 1/2 the area of the next larger square, and this square is 1/2 the area of the next larger square. The reason is because if you draw a cross in the middle, then you can see that these two and these two triangles, all of them are sort of the same. So this small white square would be 1/4 of the total area, and then this white area is also actually 1/4 the total areas. Or not 1/4. This one would be 1/4 of the total area, and then this one would be what would it be? It would be 1/2 of the total area. So basically, you can think of it as layering squares. So this dark one has an area of 1. This one has like an area of 1/2. This is 1/4, and this is or wait, actually. Okay, I might have messed up on this one too. Oh God. Okay.
Wouldn't the black area be larger though?
Yeah, it would be. Okay, yeah, I kind of messed up on that. I did not do great on this Kahoot, sorry.
No, but it says like what part of it was the black area.
Yeah, that's the thing. The black area wouldn't be, oh my gosh, I always say one. The black area wouldn't be the exactly, it wouldn't, basically I kind of messed up on calculating the area, so yeah. Anyways, who's always Psy? Oh
Me.
wow. Oh, okay. Wait, hold on, but then why are there 2 here?
Yeah.
Why? Wait, you joined twice? Wait, were you answering like on 2 devices? Or
No, the same device. Yeah. And
did
then
you have 2 browser windows, or was it like,
yeah.
oh my gosh, okay. Well, May and Always Sai are the same person apparently. And Manasvi, Anand, and wait, let me replay it because I didn't see the runner-ups. Okay. All right. Well, good job, everyone. And yeah, homework will still be like posted on the Google Classroom, but the answers will be sent out to your parents since we won't be going over them in class. And yeah, I mean, okay, one last thing. Since this is the last week, I just want to say that I hope you guys learned something, and I hope I had a lot of fun teaching you guys. This is the last week of this class. By the way, in the future, if you're going to be going into 9th grade, you can actually be a teacher here if you really want to. We're going to open an application. So if you decide that you would like to also help us teach at Mathema, we'll open an application for if you're 9th grade and up. So, yeah, I hope you guys had fun this week and you learned something. And so
The last day, you said the last week.
yeah, this is just the last day of this week. Next week, there still will be another class session. It's just for this week, it's the last day.
Yeah.
Okay. All right. So yeah, I hope you guys have a great day.